We are in the context of a pretty exciting announcement by the current administration that we have our sights set through Project Artemis at a 2024 return to the moon with the next man and the first woman. Could you say anything about the overall value of space and why everybody should be excited about what NASA and about international space cooperation brings to the human race?
Oh my goodness. Well, it is really an exciting time. The moon landing, I really do feel, is a human triumph. So this is just our species is celebrating 50 years beyond our own planet, beyond our home. So this is very exciting. And absolutely, the legacy from that program really, I think, just is something that all of us can share in together. It's something that unites us. And I think that is a really powerful binder among all people here on Earth. And one day may be something we can celebrate when we're out beyond our own home planet. For the benefits of NASA to people here on Earth, there are so many. I would say for myself personally, just the inspiration of space and space travel and wondering, who are we? How did we get here? How, many other species might there be out in the universe? That kind of deep questioning is really exciting and powerful. And also, though, there are some really more maybe direct in your life kind of influences. So everything that NASA does, we do to benefit people here on Earth. So we employ lots of people for sure, but also all the technology that we develop, we make that publicly available, and then it's used in things like your cell phone. If you have one, it's got NASA technology in it. If you fly in an airplane, NASA's with you when you fly. All the technologies that we're trying to develop to go back to the moon and onto Mars, those types of things, the resources that we'll be using, the recycling programs that we'll have to make use of, miniaturization of products, all of that will be relevant in some way to people here on Earth. So we definitely are very excited about sharing that. And then the international partnerships, I also think, are just so wonderful. For one thing, space travel is incredibly hard. It's really complicated, and it takes a lot of very smart people working all together to go out. Even our own exploration of the Earth we do with international partners, because it is a scientific community that knows no political boundaries. But because we do have lots of countries, I think that having science bring people together across borders in peaceful exploration and big questions, I think is just a really wonderful way of showing us all how interested we are in the same things, and that we can help each other together get answers to the most exciting questions that I wonder about. Anyway, hopefully many of you do too.
What got you interested in space? You work at NASA now. To many people, this might seem like the dream job. What took you down this path? What was your interest?
Well, it is a dream job. Everyone should come work with me. I encourage you all to come out here. But I think really my interest was started with my parents when I was little. They took me camping. They took me to national parks. They took me outside and showed me mountains and oceans and places around the world that I started wondering, why are they here? How did they get here? They took me to parks. I grew up in New Jersey, not too far from New York City, so our skies at home were not incredibly impressive. However, when we went out to dark sky sites, I got to look up, and the fizzing universe is just spectacular. And I had trouble deciding whether I wanted to be awake during the day or at night, because everything was just so beautiful everywhere. But that kind of exposure, I think, really led me to be interested in geology, in the study of the Earth, and the study of, how things look the way they do, how they're changing over time. I was fascinated to find out that the continents are moving around and things were different at different times, and there are fossils, and life has changed here on Earth so much. That really intrigued me. And then I went to college and found out that my interest in astronomy and my interest in geology could be combined into this field I had never heard of before, called planetary geology. And so I started studying Mars and Venus and Mercury and other rocky worlds. And that was just amazing. Had a really good time with that. But I really like to teach also. I like to get other people excited. So I took some time after college to work at a science science camp. So I was at an outdoor science school and took kids on hikes through the mountains of California, exploring rocks there, and also birds and lichen, and teaching astronomy as well as archery and line dancing and things like that, which was great. And then I took another stint out at a park in Utah. I worked at Canyonlands National Park for a little while and got to talk with visitors about the great geology there, as well as some of the stars you could see overhead in that part of the world. And then missed science, so I went to graduate school at the University of Arizona and got to work with HiRISE, a high resolution imaging science experiment on board a Mars orbiter, and that was amazing. I got to find out, real time images of Mars coming down. I got to see them and learn about them and share, snippets of what we were discovering with people, and then do my research using camera imagery that could see you if you were walking around on the surface of Mars. It was really incredible. And from there, I just was hooked, and I loved being involved in that, but I really missed talking to people about it. So my favorite part as a grad student was leading the tours and sharing the science with people. And so I found a job at NASA that I get to hear about all of the planetary science missions that we do and all the research that we're conducting. And instead of doing the research myself now, I get to share it with other people, and I get to work with national parks around the country and internationally. I get to work with, universities and partners all over the United States and even abroad. And just share NASA's planetary science exploration with people who are interested all over the world. And it's amazing. I get to work with great scientists and science teams and help them get involved as well, and set them up to talk with different people about the work that they do. And it's all great fun. So I hope you come join us at NASA.
You mentioned you were working with HiRISE, getting imagery of Mars. We had Curiosity on Mars. Recently, people were very excited about the New Horizons flyby. Let me ask, when we do these kinds of missions, is this adding a little bit more knowledge, or sometimes do we realize, wait a minute, the books were wrong. We were told we made a big mistake. This has revolutionized our understanding. What are are there any big changes in planetary geology that have come during your career?
Oh my goodness, all the time. Absolutely. I mean, you mentioned New Horizons, and that is just a spectacular example. I mean, we really didn't know what we would find when we went out to Pluto. It's such a remote world. But flying by and seeing mountain ranges of water ice, and seeing glaciers, and seeing that there's an atmosphere around this very distant world, and that the surface is renewing and younger than we expected. It's a dynamic world. That was totally unexpected. I mean, we knew that we were going to see something exciting. That's why we went, but we really didn't understand or appreciate the real surprises that little world really had. So that was just completely unexpected and just amazing, because if that Kuiper Belt object has so much to offer, and it's not the biggest one out there, and it's got so much company, so many friends, there really is a whole other part of the solar system that is yet to surprise us, I'm sure. There are lots of other examples, but given that this is the Apollo anniversary, something to talk about the moon a little bit, the Lunar Reconnaissance Orbiter has also led to some great surprises and rewriting of textbooks. So some of my favorite discoveries are that we have found out that the lunar surface is also still active, more active than we had thought. There are new impact craters forming all the time. And since we've been at the moon for 10 years now, we can see those impacts forming, and we can monitor them and understand the current impact rate in our part of the solar system, which has implications for all of our neighbors nearby, because we use the lunar surface and our Apollo samples to extrapolate dates of surfaces throughout the inner solar system, especially. So that's really, really important. We've also found evidence that the moon may even still today be shrinking, which is so neat. We found evidence of scarps or places on the surface that have a crunching of some of the surface there. And that is just really, really cool. It's kind of shrinking. We gave the analogy in our press release, like a raisin as a grape. You see the ridges on there. Well, that is the same ridges that we see. I kind of like thinking of also like a souffle that comes out of the oven hot and then it contracts over time. The moon is still shrinking, maybe even today. And we knew, this is really bad. Please edit this. But we knew about the scarps even during the time of Apollo. But with the Lunar Reconnaissance Orbiter, we have been able to see evidence of those scarps around the entire moon. So we can actually see evidence that this is the whole moon shrinking very slowly, a very little bit. Don't get worried. The moon will still look big and bright to your eye when you go outside. But it is still active, which is really neat. And we've also found evidence of recent volcanism. So recent doesn't mean yesterday, but I'm a geologist, and we found evidence that maybe in the past few million years, some volcanism on the moon has been occurring, and that is amazing. To a geologist, that's like yesterday. So it really means that maybe this could even still occur. And we found types of volcanism on the moon that we didn't expect, but considering the moon as an active world is really, really exciting. And also our discovery and our multiple discoveries of water on the moon in multiple different ways has been exciting, because that will, of course, have great implications for future exploration of the moon. If we have water deposits there that we're able to make use of by astronauts on the surface, and potentially as, a source of rocket fuel or something that could be turned into rocket fuel to go on to Mars or other places, that's going to be a really, really exciting resource to learn more about when we go back to the moon.
There's a lot to do out there. Yeah, let me
condense my responses here. I'm sorry. I get very excited.
I have too much, not enough. No, that's I think it's all worth hearing. I mean, the part you asked for the editing, we'll edit that. 2 more questions?
Yeah.
Okay, great. So, well, one is, maybe it's almost 3. Okay. I know that you do a lot of outreach work with young people, students, and people in other ways. I'm really curious about what kind of questions or what kind of responses do you often get from young people, and maybe if you have anything you've noticed about how their responses differ from older people.
Well, I love getting questions from everybody. It's just so fun how the moon is really something I feel like people have a personal connection to. Everybody can see the moon no matter where you are on the planet. The moon peeks out from time to time, and so many kids see it following them home, or people go on, hikes through the mountains with the moon guiding their way. And so everyone has a story or a memory. And so I really like it when people share their stories with me. So that's really exciting. Questions are so fun because people wonder about things they're familiar with. And so we get a lot of questions about, how come the moon's only visible at night? Well, the moon is not only visible at night. The moon is up just as much during the day as it is at night. And that's just not something we really notice as much because the sun is there and it's so bright. And also the bigger phases like the full moon and the gibbous moons, those are out at night, whereas the crescent moons are higher in the sky during the day. So those are some things that I hear a lot, and I get a lot of questions about, have we really walked on the moon, or how come we only see the same side of the moon? Because people are very observant and do notice that, the same face of the moon is facing us all the time. So those are really fun to explain. And, are we going back? Can I go to the moon? Those are fun questions too.
Do you think that there's something in the human psyche, in the human spirit, that are we meant to be a spacefaring species?
Oh, I think so. You're asking someone at NASA, so I have a very skewed opinion here. But I just think that humans wonder. We all want to know, what's beyond that tree? What's beyond that horizon? I mean, that's how we became distributed all over our own planet. We didn't do it because it was easy and because, it was something that we had to do. It was because we wanted to. We wanted to find out what was over the next horizon. And so we did, and we still have so much to learn about our own planet. We have ocean floors to explore, and trenches, and forests and deserts, and other places still to learn more about. But I think that we're always trying to learn more, and I think that space just gives us a great opportunity to find out more about our own planet. If you want to understand a tree in the forest, you don't only study the tree itself, you also monitor the rain falling around it. You want to know how much sunlight it's getting, what animals are around it, what slope it's on, all of those things. So you have to really understand the context. And if our Earth is that tree in the forest, well, then the solar system is our whole forest around us. So we have to learn about the other planets and the other objects in our neighborhood in order to understand, really the context for our own planet and what might happen to it, and where it came from and where it might be going. So, and I think then, the whole universe provides even more context for that. So we can really better understand ourselves by looking beyond our home.
Well, that's wonderful. I do have one more question, if I may. Specifically on the moon, a couple things. One is that the only geologist who went to the moon, Harrison Schmitt, had later on looking through the samples realized that helium-3, a particular isotope of helium, does exist within the regolith on the moon. It doesn't reach the Earth due to our magnetic belts, preventing that coming from the solar wind. So some people have proposed the mining, basically the processing of the regolith in order to create helium-3 as a resource which could be used for fusion fuel. Another thing about the moon that's been proposed is doing radio telescopy on the far side at some of the wavelengths that simply can't reach the Earth, and for which you need a large array, so that using one satellite simply is just not possible for it. Do you have anything you could say about some of the longer range missions for what we could do to the moon after Project Artemis brings us back in 2024?
Well, yeah, I really like you bringing up Harrison Schmitt, or Jack Schmitt, because our team, the Lunar Reconnaissance Orbiter team, still works with him, and our project scientists and others on the team just recently published a paper with him using Lunar Reconnaissance Orbiter data to reinterpret the places that he walked on the moon. So he was there, and he will sit in our Mission Operations Center and look at the images that are coming down and look at the other data that's coming down from our current spacecraft to really better understand where he was, what he saw, and together with the orbital assets plus his on-the-ground information plus the samples that we've collected, or he helped collect with colleagues, then he is able to really offer a neat perspective on, the moon and the surface and what we know about it. So he's a really fun person to be talking about. So in terms of the resources at the moon, absolutely. We know that there are lots of volatiles and other things that are trapped, especially at the poles of the moon. And so that is something that we're going to have to learn more about. And the potential of helium-3 mining, I know, is definitely being discussed by many people. So that's something that we can consider, whether it's a resource we could really make use of, and certainly the far side. But I think that we're really looking to go back and figure out how to live and work in a long time frame on the moon. And so once we're there, I know that there are, everyone you ask would have a different opinion of what we should do, because there's so many things that we could do. But questions about our Earth-Moon system, I think, are things that are still waiting to be addressed. We've been, several times. We've landed on the moon just a few times, but all on the near side, all near the equator, because those were the easiest places to go. I feel like there's a lot of interest in going to, collect samples from the far side and from the South Pole Aitken Basin, which would give us a deeper view into the moon's interior than we've ever been able to get before. And also, just other terrains on the moon that we haven't sampled. Those are going to really tell us a more complete story. Because, by studying the moon, we do learn about the moon, but we also learn a lot about the Earth. The Earth is a fabulous recycler. We are a great planet of recycling. We have taken a lot of our old crust and churned it back up by, subducting it again, remelting it and re-erupting it in new volcanoes, and our oceans and our winds and our water all really destroy a lot of the surface of the earth. So if we want to understand where we came from, the baby pictures of the earth, I like to think, are held on the moon. So if we want to see ourselves as we used to be, we have to look up to the moon to tell that story. So I think a lot of the rocks and the samples are going to be something exciting to collect from different areas on the moon. And the volatiles recorded, the things that turn from ice into gases really easily, like water on the moon, that will be something we can study at the poles and really get a record that goes back potentially billions of years, or at least millions, or who knows. Actually, I've not been there. No one's been there, but we're hoping that it's a really long-term record that we can see recorded on in those core samples, potentially from the ices at the moon's poles. So lots of science questions to ask, and we're actually capturing a lot of those now. So NASA is talking with scientists across the agency and our partners all over to ask the questions or to find out what questions we do want to ask and figure out how to address them when we do go back to the moon with Artemis, and then over the long term with our Gateway and our other plans for lunar exploration. There's so much going on. It's very exciting.
Exciting. Okay, well, thank you so much, and we are really looking forward to hearing from you live on July 20th on the 50th anniversary. And thank you so much for your time. This is a real inspiration. Thank you very much.